So I'm getting a lot of questions about frequency tables, so I wanted to go through another example nice and slow and in a lot of detail. So here's an example of some data that's been collected, and this is data that was collected for a rating. The question says, does a teaspoon of honey before bed really calm a child's cough? So some pediatric researchers wanted to see if this helped, and so they gave honey to kids that were sick. And then there was a rating that parents would give for the cough between 0 and 30, 0 being no problems at all, and 30 being extremely severe. So these are the ratings that the parents gave after honey was administered. And of course, they had a control group and they tried some other things too, but we're going to focus on the data that was collected based on the honey group. So we want to make a frequency chart based on this data here. So the first thing I suggest is to put all of this data in your calculator, because the calculator will help you sort and organize the data in a way that it makes it easy to count and find the values. So to do that, you're going to hit the stat button here. And then you're going to click on number 1, which says edit. And you're going to enter your data. I put mine in L1. You can put it in any column you wish, but I put mine in L1. So you're just going to hit the 1, 2 button and then enter, and then put in 1, 1, hit enter, and go through and make sure all the data values are correct. And then also you want to make sure that if you had a list in there previously, that you clear it out so that you don't have any additional data values in there floating at the bottom of the list. Now, I already have mine pre-entered, so go ahead and pause the video and take a minute to enter this data in. Once you have the data in, some quick features I want to point out. If you scroll through the data, you can see down here it's labeled what list you're highlighted on, where your cursor's at. This is list 1 and this is entry 6. So number 13 is the 6th number down. So if you want to make sure you have all your values in there correctly and you didn't miss anything, you can double check by eyeballing it, but then you can also make sure that you didn't miss any values by scrolling down and looking at the last value. If you notice, the last value is 12, and if I highlight 12, it says it's in list 1, item number 35. So if you count the data values in this list here, there's 35 of them. So I know I didn't miss any values. Okay, once you have all your data values in there, what you want to do is you want to sort the data. And this is where it really comes in handy. Now, if you have a small data set like 5 to 10, it might be easier to just eyeball it and do it by hand. But when you have a larger data set, using the calculator makes it so much easier. So we're going to sort the data. So we're going to hit the stat button again. And then under option 2 and option 3, it says sort A and sort D. They both sort the data, but one sorts it in increasing order and one sorts it in decreasing order. So option number 2 says sort A for ascending, which means it goes from lowest to highest. Sort D is sort descending, which means it goes from highest to lowest. It doesn't matter which way you sort it. I prefer using sort A, but you might prefer sort D. So I'm going to choose option number 2. And then I'm going to tell it to sort my list 1 because that's where that's where I have all my data. So you might have your data in list 2. So you want to make sure you put list 2 in here, or whatever list it is that you're using. So your list variables that you see on your keypad are above the 1, 2, 3, 4, 5, 6 button. See, it says L1, L2, L3, L4, L5, L6. So these are your list buttons. So I'm going to choose, since I put my data in L1, I'm going to hit the second button and then L2 to access that L1. Now your calculator should be color coded. So since my L1 is in blue, I know that I need to hit that blue button first. If I was trying to access something that was green, like say I was trying to access the solve option here, that would tell me that I would have to hit the alpha button first and then the enter button. So it's color coded to make sure that you know which button to hit first. So I hit the L1 button and then I'm going to close my parentheses and then I'm going to hit enter. And it's going to tell me that it's done sorting. So now when I go back to my stat button and go to edit, you'll see that the list of all the data values, all those numbers are still there. It's just rearranged from smallest to largest now. So I can easily see what my min and my max numbers are. Okay, so my minimum is 3 and my maximum is 16 for this data set. So now that we have the data sorted, we're going to find the class width. That means for each of the classes, for each of the intervals that we're going to set up in this table, we need to figure out the lower and upper limits, and we need the class width for that to see how wide each interval is. So to find the class width, we're going to take the maximum minus the minimum and divide by the number of classes. So in this case, our maximum was 16, our minimum was 3. So when I take 16 minus 3, I get 13, and then I divide by 3, that's going to give me 4.333 repeating. Now, whenever you find the class width, you always want to round up. Even if it comes out to a whole number, if it comes out to 4, you still want to round it up to 5 because we want to make sure that the upper limit of that last class goes out far enough to contain the maximum value. And if you round down, sometimes that doesn't work. So we always round up to the nearest whole number. So in this case, we're going to round up to 5. So this is our class width. Let me highlight that. Okay. Now, when we start figuring out what our lower and upper limits are for the classes, you always want to start for the lower limit of the first class. You always want to start with your minimum value, which is 3. Now, because our class width is 5, we want to make sure that that interval contains 5 values, and that includes the endpoints. So we want 3 as the first value, plus we want 4 more values. So I'm going to take 3 and add 4, and that's going to give me 7. Now, our intuition tells me, well, if I want a class width of 5, why don't I just add 5 to 3? Well, what's going to happen is, because we take 3 plus 5 more, that's going to give us a total of 6. We want 5 numbers on the interval from the lower limit to the upper limit, including the endpoint. So if you count on your fingers, 3, 4, 5, 6, 7, that's 5 numbers for a class of width of 5. Now, I want to make sure that my next one, the lower limit of my next class, starts at the next whole number. So we're going to start from 8. And then again, because we want 5 numbers on this interval, I want to start at 8. 8's going to be one of the numbers, plus I want 4 more. So it's going to go from 8 to 12. And then I start at the next whole number down here, 13. And I'm going to add 4 more to get 17. Now for the lower boundary and the upper boundaries, we want to fill the gap. Because later on in the next chapter, we are going to start drawing histograms, and we use frequency tables to draw histograms. And when we draw histograms, we don't want any spaces between the bars. We want the bars to be butt up against each other with no gaps. Now, if I leave it like this and I use these intervals to draw my bars, there's a gap between 7 and 8. There's 7.1, 7.2, 7.3. There's all these numbers between 7 and 8, so there's a gap. So we want to make sure that we fill the gap by going out a little bit on either side of the upper and the lower limits to fill that gap. Now, because these are all whole numbers in this data set, we want to go out a half in either direction. So for the lower boundary, I'm going to go a half past 3 to the left. So it's going to be 2.5. And then I'm going to go from 7, I'm going to go out a half to the right. So that's going to give me 7.5. Then when I start down here, if I take 8 and I go a half to the left, that's going to give me 7.5. And then if I go a half to the right of 12, that's 12.5. So now notice I close the gap. I'm going from 7.5 to 7.5. That's my starting point. So this is what we're going to use, the lower and the upper boundaries later to draw the histograms because this closes the gap. And then down here we have 12.5 to 17.5. Whoops. Now, you're probably asking yourself, which is a great question, well, why didn't we just make this 7 here and close the gap here and save ourselves the step from doing the boundaries? Well, the reason why we don't want to make this 7, let me give you, I'm going to actually make a mistake here on purpose, so don't write this down in your notes. If I close the gap here and I write this 12 here and I make this 12 here instead, so I close the gap here, what's going to happen is when I go to count my frequencies, if I go to count and see how many 12s there are, there's 1, 2, 3, 4, 5, 6 12s if I counted correctly. So when I put down any 12s, what interval do they fall on? Do they fall in this interval or do they fall in this interval? Where do I count the 12s? Do the 12s fall on the second or the third interval? So that's why we want to leave no, we don't want the upper and the lower limits to be the same here because it's confusing on where those values fall when we're taking our counts. And that's why when we do our lower and upper boundaries, which is what we use for our bars in the histogram, we go out one more decimal place. So by using these numbers, 2.5, 7.5, 7.5, the 7.5s, I know that there are no decimal values of 0.5s in here because they're all whole numbers. And that's why we set this up. So my boundaries, I'm not going to run into the problem of trying to figure out where the value falls because I know there are no 7.5s in my data values. And that's why we always go out one more decimal place for our boundaries so that we know that those values in the data set is not going to get confused on where to put them, what class they're going to fall into. All right, now for the midpoints. To find the midpoints, we want to find the midpoint between 2.5 and 7.5. Where's that halfway point? Now, again, right now you just need to know how to find the midpoint, but later in the semester, we're going to use the midpoint to make another kind of graph. So to find the midpoint, you add the upper and the lower boundary together. So you take 2.5 plus 7.5, that gives me 10, and then you divide it by 2 to find the midpoint. So that's going to give me a 5. I take 7.5 plus 12.5, add them together and divide by 2. That's going to give me 10. 12.5 plus 17.5, that's going to give me 30. And when I divide by 2, that's going to give me 15. So for right now, just know how to find the midpoints and know that we're going to use it to draw a kind of graph. I believe it's in chapter 2. So for the frequencies, what we do is we just take account anything that falls between 2.5 and 7.5, we're going to take account of it. And this is where the calculator comes in really handy by sorting it. It helps with the count so that we don't miss anything. So because we sorted the data, anything that falls between 2.5 and 7.5, I just go down the list and count. As soon as I hit over 7.5, I stop counting. So I have 1, 2, 3. Notice I'm just using my arrow to count and go down. So I started at 3, 5, 6. That's 3 values. When I get to 8, that's over 7.5. Whoops. So I don't count that. So there are 3 values in our data set that lies between 2.5 and 7.5. So that's a frequency of 3. Then when I go through and look at the calculator and count how many values, I just scroll down, count how many values I have between 7.5 and 12.5, you're going to find that there are 24 values. When I just scroll down and I count as I go down, as soon as I go over 12.5, then I stop. I don't want to include those values in that interval. So if you count down, you're going to see that you have 24 values on that interval. Then if you count the number of values from the data set that's between 12.5 and 17.5, you're going to see that there's 8. For relative frequency, that's just asking the proportion or the percentage of values that fall on that interval. There's a total of 35 values here. So the relative frequency here would be 3 out of 35. And of course, you can put it in decimal value, which would be, if we round it, about 0.09 or 9%. And this is approximate because we rounded. So I'm going to take, for the relative frequency for this column, or this row, I'm going to take 24 out of 35. And of course, you can put it in decimal form, which is fine. Just read the directions when you're doing your homework to see if you need to put it in decimal value and how many places to round. And then for the next column, we have 8 values in this interval out of 35, which gives us a decimal value or a percentage. Whoops, 35. Now the cumulative frequencies, or the cumulative relative frequency, you got to pay attention to whether it says cumulative frequency or cumulative relative frequency. That cumulative means to add up, okay? So if it just says add up the frequencies, then you're just going to start here in the frequency column. I start with 3. In the second row, if I add up the two frequencies, 3 and 24 together, that gives me 27. And then if I add everything up to this point, I'm going to take 27 and then add in the 8, which would give me 35. Now, in this class, I like to use this just as a check to make sure I got all my values in here and I didn't miss any, because this should total up to how many data values you have. But there's also a cumulative frequency graph that you can look up if you're interested in knowing what that is. That's called an ogive, and it graphs the cumulative frequencies. Now, for the cumulative relative frequency, that means we're going to add up the relative frequency columns. So this column would be 3 out of 35, or you can do it in decimal format. Either way, it's fine. Just know if you do it in decimal format and you round, it might be a little bit off from 1 because of rounding, but you should get 1 at the end. If I take 24 out of 35 and add it to 3 out of 35, that gives me 27 out of 35. And then if I add the 27/35 to the 8 over 35, that gives me 35 out of 35, which is equal to 1. So this is how you want to set up a frequency table. And like I said, right now we're just learning how to set this up, and we're going to apply how we're going to use this to make graphs in the next chapter.